The TPP and TPI series of 180-watt AC/DC power supplies both hail from Traco Power. Both series come in enclosed and open versions. The electrical specifications for both series are identical except for two: leakage current and isolation voltage. TPP supplies are designed to keep leakage current below 100 microamps. This makes the units suitable for body floating medical applications.
Both supplies feature reinforced double I/O isolation. The TPI 180 is isolated to 3000 volts, while the TPP 180 is isolated to 4000 volts. According to the latest medical safety standards, both have energy efficiency of up to 94%, which lets them fit in a compact 2 by 3 inch open frame or 3.6 by 2.44 inch enclosed package. They operate over a -40 to +85 degrees Celsius range with a D rating above 50 degrees Celsius. With natural convection, these supplies deliver up to 150 watts, going up to 180 watts continuous with the addition of forced air cooling. Additionally, they can deliver 220 watts peak power for 5 seconds.
We fired up a TPP supply to illustrate a few of its specifications. The output voltage can be adjusted by about 8% using a screw head sitting near the output terminals. We've adjusted it to get the supply's rated 24-volt output into a 4-ohm load, which puts the supply output near its 150-watt rated output using only natural convection. The connections to the output are made via 2 clamping terminals actuated with Phillips screw heads.
As we mentioned, these supplies can be up to 94% efficient, meaning that all but 6% of the power into the supply is delivered into the DC load. We can't really demonstrate efficiency with the instrumentation we have here. The problem is that for the high efficiencies that these supplies provide, even small measurement errors in the input and output power lead to large errors when calculating power loss. For example, if there is a measurement error of just 0.5%, the power loss calculation would be wrong by 20%. And measurements we make on the AC input will be for the apparent power rather than real power. For precise measurements of AC input power, you really need either a precision watt meter or a power analyzer.
But we can show you the AC current drain when the supply is powering near its maximum load. Our clamp-on ammeter shows it's about 1.1 amps for 120 volt AC lines, bringing us pretty close to the 180 watt rating these supplies have when they are cooled only by convection.
Another specification of interest is the supply ripple and noise level. This unit puts out 24 volts. The spec is ripple and noise below 220 millivolts peak to peak over a 20 megahertz bandwidth. Put another way, the ripple and noise is less than 1% of the output voltage.
Ripple voltage is also known as PARD, or periodic and random deviations of a DC voltage. We see it as deviations caused by periodic sources like the switch mode converter's switching frequency and random sources like thermal noise. The difference from the top to the bottom of the waveform, or the max to min voltage, is the ripple voltage. In other words, ripple is the AC component of a DC voltage. To measure ripple correctly on a switch mode power supply like we have here, the supply needs to be powering some kind of load so the supply regulates itself. That's why we've got this supply powering a couple of power resistors for this test.
For making measurements of small signals like the noise on a power supply output, you typically want to fill the oscilloscope screen with the signal. The best way of doing that in this case is with a scope setting called DC offset, which just displays the AC part of a DC signal on the scope input.
Unfortunately, the scope we have doesn't include a DC offset feature, so the other way we can get rid of that offset is by changing the channel coupling from DC to AC. When we do this, we put a series capacitor into the signal path, which takes out the DC component. The caveat is it also removes some of the really low frequency noise below 10 or 20 hertz. So bear that in mind when viewing our results.
Another point to note is that most oscilloscopes have a 20 megahertz filter built into them intended for power supply measurements because the power supply noise spec typically specifies a 20 megahertz bandwidth. That's the case with our scope. We are measuring output ripple and noise with the 20 megahertz filter switched in. When we finally do make a noise measurement, we find that it is typically well below the 200 millivolt spec. In fact, we typically only see 20 or 30 millivolt noise using our power resistor dummy loads.
That brings us to the EMC specifications. These supplies meet international EMI emissions standards that include EN 55011 and EN 55032. Both meet Class B for conducted emissions and Class A for radiated emissions, which means the supplies are appropriate for industrial as well as consumer applications. We can't do a full EMI test here because we need specialized equipment that includes line impedance stabilization networks and specialized receivers and transceivers. But we can give you a feel for the supply's radiated emissions using a homemade inductive pickup which we place near the supplies. When you do that, you find the radiated emissions are essentially non-existent until you get within an inch or so of the open supply, and you have to get even closer to see any EMI from the closed version.
Moving on, the startup time for these supplies is under 1.5 seconds. We can illustrate that with this push button that we've wired in series with the AC input. When we push the button at the center line of the scope display, we can see the supply output respond well within the 1.5 second spec.
We can also use our push button to illustrate the supply's hold-up characteristic after AC power is removed. With a load on their output, these supplies hit zero output within 10 milliseconds of when AC power is removed. Finally, we can look at how the supplies respond to a load step. And for that, we have a three-way switch wired into the two power resistors we're using as the dummy loads. When we flip the switch, it takes one of the power resistors out of the supply circuit. The typical transient response when we do this is on the order of less than 100 millivolts with ringing that typically lasts only for a millisecond or so.
And that's about it for the TPI and TPP power supplies from Traco, candidates for use in industrial and medical devices and for demanding safety and space-critical applications. Thank you for watching. You can see more videos like this one at eeworldonline.com.